With this next section, we're going to be looking at right triangles, and we're going to actually introduce trigonometry with this. So with trigonometry, we have these special ratios that we can use to set up missing angles and sides. For this video, we're going to focus on those missing sides. So starting at the beginning, we need to talk about what trigonometry is. So trigonometry is the study of triangle measurements. So again, talking about those angles and those sides. With trigonometry, we have three different ratios that we can set up. So we have sine, cosine, and tangent. Sine is talking about the ratio of the opposite leg and the hypotenuse for a specific angle. So they're always going to give us an angle to look at, and we're looking at the opposite side and our hypotenuse. Looking at that example for the sine of A, so we read that as sine of A, not sin of A. Looking at angle A, the side opposite is the little a, and my hypotenuse is little c. So when I write that ratio, it's A over C. Looking at the sine of B, I start at angle B. The side opposite is little b, and my hypotenuse is C. So when I write that ratio, it's B over C. The cosine is when I'm looking at my adjacent side and my hypotenuse for a specific angle. So cosine of A, we're going to start at angle A. The side opposite was A, so the adjacent side in this case is B. And then my hypotenuse is little c. When I write that ratio, it's B over C. When I look at the cosine of B, I'm starting at angle B. Remember, little b was the opposite side, so my adjacent side is little a. And my hypotenuse never changes, it's always the little c. So when I write this ratio, it's A over C. Tangent is when we're looking at the opposite side and the adjacent side for a specific angle. So we're leaving out our hypotenuse entirely, and we're just looking at our legs. Looking at the tangent of A, again, not tan of A, we say tangent of A. When I look at angle A, the side opposite is little a, and the side that's adjacent is little b. So writing that ratio, I have little a over little b. When I look at the tangent of B, I look at angle B, the side opposite is little b, and the side adjacent is little a. So that ratio is B over A. When we look at these ratios, the shorthand that we have to remember is SO, CA, TOA. When we say that, SO stands for sine is opposite over hypotenuse. CA is cosine being adjacent over hypotenuse. And TOA is the tangent of opposite over adjacent. So if we can remember SOHCAHTOA, we can remember those trigonomic ratios. We're going to do a few examples using those ratios. So with our examples, this time they gave us numbers for our sides instead of letters. We're going to write out that fraction, and if we can simplify, we will. For our first example, we are starting with the sine of A. So we're starting at angle A. Remember, sine is opposite over hypotenuse. My opposite side is 5, and my hypotenuse is 13. So writing out that fraction, I have 5 over 13. I'm going to go down to the cosine of A. So looking at that same angle, cosine is adjacent side over my hypotenuse. My adjacent side is 12, and my hypotenuse is 13. So that becomes 12 over 13. The tangent of A, remember tangent is opposite over adjacent. My opposite side is 5, my adjacent side is 12. So that ratio is 5 over 12. We're going to do the same thing for our second set, but this time we're doing it from angle C. So from angle C, doing my sine, I'm looking at opposite over hypotenuse. Opposite is 12, it's the side across from my angle, and my hypotenuse is 13. So looking at that ratio, it's 12 over 13. Looking at the cosine of C, cosine is adjacent side over hypotenuse. My adjacent side is 5 because my opposite side was 12. So I'm going to do 5 over my hypotenuse of 13. Lastly, I'm going to look at the tangent of C. Tangent is opposite over adjacent. Opposite is 12, adjacent is 5. I write it together as a fraction. Number 2 and 3 are going to be done the same way. The only difference with 2 and 3 is that we see there's a little bit of work to the side here. They gave me my right triangle, but they didn't tell me what that hypotenuse was. So on the side, I had to use the Pythagorean theorem to figure out what that missing side was so I can set up those trig ratios. Now that I know that my hypotenuse is 15, I can easily find the sine, cosine, and the tangent. So for number 2, starting at angle W, I'm going to do the sine, so opposite over hypotenuse. Opposite of W is 12, and my hypotenuse is 15. It is 12 over 15, but we need to simplify if we can. 12 over 15 simplifies to 4 over 5. We're going to do the cosine now from angle W. Cosine is adjacent over hypotenuse. So I'm going to do the adjacent side 9 over my hypotenuse of 15. 9 over 15 simplifies to 3 over 5. Then looking at the tangent of angle W, I do the opposite side over the adjacent side. Opposite side is 12, adjacent side is 9. 12 over 9 simplifies to 4 over 3. That second column, the sine, cosine, and tangent from angle X is done the same way. Again, we have to make sure we simplify those ratios if we can. Number 3, I'm going to go ahead and just show you those answers. Remember, for number 3, we had to start with that Pythagorean theorem so we could find our missing side. Once we find our missing side, we're setting up those trig ratios, and we're always simplifying if we can. Remember, Desmos will help you simplify if you're having trouble seeing it. You just put it in and see if it simplifies it for you. Now we're going to turn our attention to finding missing side lengths using those trig ratios. With all of the examples we just looked at, we had a letter next to the sine, cosine, or tangent. That letter stood for an angle. So looking back, we had W as an angle, we had L as an angle, we had C as an angle. When we're finding missing side lengths, we are actually using a degree measure for our angle. So we're going to base it off of that angle measure. We're still going to write our ratio, but instead of a letter, we're going to write 28 degrees. So looking from my 28 degree angle, I need to figure out what ratio would use my X and use my 19. Well, if I'm at 28 degrees, X is the opposite side and 19 is the hypotenuse. Opposite and hypotenuse goes with sine. So when I write out that ratio, when I write out this problem, it's going to be the sine of 28 degrees equals X over 19. So angle on the side and my ratio on the other. Then I'm going to solve for X like I normally would. When we solve for X, we are going to first get rid of the fraction on the bottom. To do that, we're going to multiply both sides by 19. So this becomes 19 sine of 28. We are actually going to type 19 sine of 28 into the calculator in one complete row. When we look at Desmos, we get all of our trig functions when we hit the functions button in our keyboard. So once I hit functions, I get sine, cosine, and tangent. Once we type that into the calculator, we're going to round to the nearest tenths place, just like our instructions said. Looking at number 5, again, we want to figure out what that ratio is going to be. We always start with the angle that they gave us, so in this case, 41 degrees. I want to figure out what ratio uses my x and my 32. From 41 degrees, x is my opposite side, and 32 is my adjacent side. So what uses opposite and adjacent is tangent. When I write that out, I'm going to have the tangent of my angle, so tangent of 41, equals x over 32. Again, we're going to solve this equation for x by multiplying by whatever our denominator is. When I do that, I have 32 times the tangent of 41 equals x. I plug that right into the calculator, and then I round to the nearest tenth. For number 6, again, we need to set up that ratio first. Looking at my angle, I'm looking at 21 degrees, and I want to figure out how to use x and 26. X is my adjacent side, it's right next to it, and 26 is my hypotenuse. Adjacent and hypotenuse go with cosine, so when I write this out, I have the cosine of my angle, 21, equals x over 26. Again, we're going to multiply by my denominator, get 26 cosine of 21, plug it right into the calculator, and get my answer. Number 7, looking at that ratio, we're starting at 55. I'm using x and 8. X is the opposite, 8 is my adjacent. Opposite over adjacent is tangent. So I have the tangent of 55 equals x over 8. Multiplying both sides by 8, I find that x equals 11.4. For number 8, we're going to set up our ratio first. Looking at 33 degrees, 15 and x, I have opposite over hypotenuse. Opposite over hypotenuse is sine. So the sine of 33 equals 15 over x. When I do this problem, I have to still solve for x, but to do this, I'm going to have an extra step in there. So I'm still going to multiply both sides by my denominator. When I do that, I have x times the sine of 33. So I need to multiply or divide both sides by the sine of 33 in order to get x by itself. So I'm going to type 15 divided by the sine of 33 into my calculator and get that x is 27.5. So it's a little bit different when we're solving from 4, 5, 6, and 7, but again, we're still just getting x by itself. For number 9, looking at 43 degrees, 36 is my adjacent side, x is my hypotenuse. Adjacent and hypotenuse is my cosine. So I have the cosine of 43 equals 36 over x. I'm multiplying both sides by x, and when I multiply both sides by x, I still need to get x by itself on the left. To do that, I'm dividing both sides by the cosine of 43. So 36 over the cosine of 43 is what I put in my calculator to find what x is. 10 and 11 are going to be done the same way, so I'm going to show you those ratios and I'm going to show you those answers. That way we can take a look at those word problems. So with our word problem for number 12, we have that Jake leaned a 12-foot ladder against his house. If the angle formed by the ladder and the ground is 68 degrees, how far from the base of the house did he place the ladder? For this, we're going to need to draw our picture. Once we draw that picture and we label our sides, it's going to be easy to set up our ratio. Looking at 68, the angle between the ladder and the ground, x is my adjacent side, 12 is my hypotenuse, so I'm using the cosine of 68 equals x over 12. I'm solving for x the same way and getting 4.5 feet. 13, I'm going to set up a picture as well. For this one, we want to figure out how long that ramp is, so I'm finding my hypotenuse. 7 is my opposite side from 25 degrees. Setting up that ratio, I have the sine of 25 equals 7 over x, and then I'm solving for x. So when it comes to finding the missing sides of a right triangle, we're really going to use these trig ratios, and we're going to remember it using SOHCAHTOA. and that's for our missing sides.